Hello, everyone. Good morning, good afternoon, good evening, wherever you are in our virtual world. And today we'll be talking about developing your inner Spidey Sense, and it's related to anomaly detection for Internet of Things application. My name is Ron Dagdag, and I am a software engineer at Spacee. And get it ready for you. All right, anyone familiar here with Spider-Man? Most likely you've encountered them with the past movies and blockbuster movies, and how many reboots and remakes, and I bet you're familiar with Spider-Man's Spidey Senses, which is, the tingling sensation on the back of Peter Parker's skull that tells him, kind of gives him a sense that there's a danger before it happens. It tells him that there's something wrong and something going on. And it gives him that ability to detect, clones or evil, and also allows him to navigate when he's disoriented. It helps him find ways or secret passageways if lost any objects. Most likely, it also helps him. You see him throughout the buildings. To the Cody's background over there with all these different buildings. I guess that for the web shooter and can swing instinctively. Of course, he uses it also to change. I think he uses it also to change his clothes, right? To change his costume, or so that he can hide well. But in real world, there's the real Spidey sense is what they call trichobothria. I don't know if I can say that right, but it is that hairy spiders, the long thin hairs of spiders, that gives them that that low level vibration that they can detect through their web, and it can even detect sounds because of that, and identify if there's a small object, and they if there's danger, it can give them the fight or flight. And of course, if you're a new web developer, this is how it feels like. So for me, Spidey Sense is that gut feel, or that that intuition that kind of helped you, that something that you learned from the past, it kind of helped you to become good at something. Like, think about basketball players, right? Think about professional athletes, professional football players, or even baseball players. They don't think about the ball anymore, where it's going to go. They know when to hit them at the right time, at the right moment, like when to shoot them, and when to run, where to run, because of what they've learned in the past, because of practice. And that Spidey sense, that it becomes natural to them. It's a great tool, and that's what made them professionals, right? That's what made them great. So in programming languages, it's kind of like the same way too, right? You have your low-level programming language, you have your assemblies, and and before you can get to the assembly, you have a way to compile it with your higher level programming languages. So like C# and Java and all these different easy to digest languages, right? Easy to read, that gets thrown into a compiler so that so that the machine can understand. So the same way as in our body, and what I'm showing here, right? Our body, we have the reflex, we build that reflex with our instinct and intuition, right? That's something that tells you something's wrong, or sometimes it feels like someone is watching you, that kind of thing. And it goes through this interpreter module, right? Which is our nervous system to send messages up, where we can think about insights. So more when we think about in our brains, and we think about insights and what we learned and what I've identified that we can do better, those kind of things. So today, our agenda is going to be talking about anomaly detection. We're going to focus on time series anomaly detection, and we'll do some demos and some takeaways. So anomaly detection, for me, it's kind of like the Spidey Sense, right? It's that identifying unexpected items in the event of your data set. You have a bunch of data that's streaming in from your, not just from your database, or you think about it from an IoT sensor, right? And then sometimes you figure out that there's an outlier or something that's so weird. We live in the pandemic times, so that's the reason. One of the reasons why it's like I want to talk about these. I want to talk about anomaly detection because everything's so weird these days, right? The changes that's happening in our not just economy and everyday lives, it's out of normal, right? And would we consider this as an anomaly? Depends on how far you look back, right? We have the Spanish flu in the past. So maybe it happens once every 100 years, or we don't know, right? But anomalies occur very, very rarely in your data, and it's different from a normal instance significantly. So there are two types and causes of an outlier, right? There can be artificial or non-natural or natural causes. Causes of an outlier could be with your data. It could be data entry errors. If you fat fingered something, you have a spreadsheet. You type in 100,000 versus 1 million, and extra zero at the end make a whole lot of difference. Measurement error could be, which is very common when when we have sensor data that we're collecting. That can happen. Experimental error is when you're starting late in the sprint. So you have, you're supposed to collect 1 year's worth of data, and most of your data is in December. So that would skew and would cause lots of outliers. Intentional outlier would be a good example of that is underreporting alcohol consumption. If you ask teenage kids if they drink alcohol, and you'll know that there will be outliers in your data. Data processing error also. It's how you extract your data. You're reading from a database, and somehow there's some processing, how you extract that data. You transfer from one data to the other, and when you do your conversion, that can cause data processing error. Another is through sampling. Sampling errors would be you want to report all the height of athletes, and you only included a few basketball players, or you included too much basketball player. That would skew the sampling. And of course, natural, when it's not artificial, it's part of the data. It's very common. Guys, if you have any questions, feel free to place them in the chat. We can answer them later on or in the Q&A. Feel free to ask those questions. So what we're trying to do is identifying if our data set is anomalous or not, right? We're trying to figure out, based from the input data stream, it's either you have a little, defective, and the blank space there, that means it's not defective, it's normal, right? And there are instances where most of the time everything's normal. Those block boxes, your white space there, that means it's normal. And sometimes you'll catch defective, right? Your defective means can be, it's anomalous. But there's two ways. Sometimes you won't detect them, sometimes you would. So depending on that algorithm that you place in there. So in terms of confusion matrix, we're trying to figure out, okay, based from the guesses and truth, this is how you would figure out the accuracy of your formula or your system. If there's more, true positives, false positives, and you'll false negative and true negative, and the calculation between the recall and precision. I'm not going to focus more on these, but I will focus on this, right? What we're actually doing is finding the needle in a haystack. And there it is. There's that needle. If it's that big, sometimes it's not that easy. So methods and how you would do anomaly detection is through rule-based system. Sometimes it's statistical techniques and machine learning. I'm going to differentiate when to use each one of these and contrast each one. So rule-based system is when you're thinking about specific rules, right? Most likely when you're in in AEC, we have a bunch of different rules in terms of how the building is built, right? There's certain thresholds, certain regulations, height, certain weight. There's, different formulas that you have to deal with to make sure that the building is properly built, and also if there are any possible issues in the future. And we all have these different rule-based systems that kind of help us identify possible problems. So it's when you have specific rules and you assign thresholds and limits, and you need the experts to detect if there are anomaly with your data, especially when you're processing them on the field. And then, of course, one of the disadvantage of these is it does not adapt to pattern changes. And once you set up the rules, in order to adapt, we have to label the data again and change the rule set and redeploy. So I agree with this. This quote from Julius Caesar is, experience is the teacher of all things, which we all agree, right? And that's how we build our Spidey senses, is through experience. The more practice, the 10,000 hour rule that came up with that. And there's a reason why a lot of experts know about a certain topic, because they spent the time and learned through experience. And sometimes it becomes tribal knowledge, which is harder to take from, people have been doing it more and more in the past and identifying those rules, right? And learning from that expert so that we can develop systems around it. That can be challenging sometimes. Statistical techniques is when you have your data points and you use statistics. One great example is, you do your mean, median, quantiles. Sometimes you use rolling average or moving average. This is true whenever they do statistical techniques for, stock market, right? Sorry. The stock market. Also for moving averages, they have some example for Kalman filters as part of, in terms of robotics and identifying, sensor data, where you have Kalman filters. Also histogram-based outlier detection can be also part of statistical techniques where you look at the histogram, especially for image processing, right? And the advantage of using statistical techniques is it's easier to interpret compared to using machine learning methods. It's easier to calculate, and explain, hey, you take the average, right? Or show it in a graph and show the moving average compared to, any other machine learning methods. So when do you use anomaly detection and in machine learning, some supervised learning, right? When it's anomaly detection is very good when you have a very small subset of positive example. It rarely happens in your data set that you have anomalies. Or you have large number of negative examples. Negative examples, that means it's normal. It's not the abnormal circumstance. So different types of anomalies, when it's harder to learn from the positive examples, sometimes it's harder to identify that, hey, this is an anomaly or not, or based from that positive examples. And we haven't discovered all the possible anomalies that can happen. Supervised learning is very useful when you have mostly even large number of positive and negative examples, right? When you have examples, a good positive examples of the algorithm, and most likely what you're testing it on is related to your kind of like the same as your data set. So anomaly detection is very useful for fraud detection, right? You're trying, your credit card companies uses anomaly detection. And I bet you've experienced this where your credit card doesn't work anymore because you're traveling and they discovered that there's something fraud, or that happened. In manufacturing, where you have a machine or an engine that continuously run 24 hours a day, there's a pattern that you can see, and sometimes it has anomalies that happens. It kind of gives us the continuously running it, and then suddenly, hey, it didn't work anymore. But there's some symptoms before that. That's when you do predictive analytics, and one thing that might help is anomaly detection on that. Monitoring data center, they use this a lot, especially when on Azure or GCP or AWS. And Internet of Things, which is it's something that in the AEC space, I believe it's been getting useful to collect that data. Supervised learning is when one great example of it is email spam, because there's a lot of examples out there of what an email would look like and can look like. They use a lot of the supervised learning and machine learning on that. Weather prediction is also another one, because the scientists, they kind of figure out it's going to be sunny or windy or rainy and all that. There's specific set, most of the time, right? But whether there's already lots of great examples out there, and it can be classified either one of those. Cancer classification, it's not considered anomaly because you have experts that already researched about different types of cancer. And if you're doing this for a medical situation, it makes sense to use supervised learning than anomalies. So for the machine learning methods, there are three. Sometimes you can use supervised learning, where you do decision trees, SVM, which is vector machines, and LSTM forecasting. Unsupervised, that's when you do clustering or k-means. self-supervised is more a combination of supervised and unsupervised type, where you have autoencoders. I'm not going to focus more on this side, but I just want you to be aware of these different algorithms. But just to visualize what it kind of looks like, in the, could be sometimes density-based anomaly detection, where notice the thing here on the right side, where this is normal circumstance, and then this is the abnormal ones, because you can group them together, density-based or cluster-based. They can be clustered, and so these ones are anomalies because of that. And that's when you have the cluster-based, which is using k-means. Another one using Gaussian distribution, where you have you get the Gaussian distribution of your data set, and anything that's outside of that Gaussian, that is considered anomaly. That's another way. Support vector machine is when you split the data into two, and train a machine learning model based on that. So my point is, there's lots of different algorithms that you can use to do your anomaly detection. Lots of different ways, from something simple to something complicated to implement. For the Internet of Things world, the reason why Internet of Things and AEC, I think they're becoming good combination, because of the increased data volume. The sensors are getting cheaper by the day, not just camera, all these different sensors that is installed in our buildings. And also the networking, especially inside buildings, inside the built space, has been improving too, with the with the 5G network and all that. It opens up a lot of capabilities that we haven't seen in the past. But also, because it's getting closer and closer to our users, the risk environment are moving very fast, right? But if there's something wrong, with that Internet of Things, failures are not tolerated. It's sometimes, for me, it gets frustrating as a user when Alexa is down, or now I use Alexa to turn off and turn on my TV sometimes, because I don't know where the remote is and I have to find it. But if it doesn't work, it gets frustrating. so it's becoming part of our lives every day. So, and of course, this is how it feels like when you have an internet of broken things. It's trying to find the solution. And you'll hear more and more about the artificial intelligence of things. Artificial intelligence of things is the combination of, you have your Internet of Things of data and you have AI coming together to give you better insights. So, like what I've said, our bodies kind of gives us that capability of instincts and intuition, what we call intuition, more like a Spidey Sense, which feeds that data to our interpreter module, which is our nervous system, into our brains. And of course, our brains would analyze those and build insights and what we learned from that experience. And one good example is when you get into an accident. So also in the IoT world, it feels kind of like the same way, where you have your edge and gateway devices, your sensors and your cameras, right? That is installed in the buildings. And you have your device twins collecting, or the cloud collecting that information, the results of that data set. And then based from that data set, we build business intelligence or dashboards to help for maintenance, not just that, especially for BIM and improving the flow of that building, or improving the usage and facility management. So time series anomaly types, whenever you start working with time series meaning, you have your data, right, from the sensors, and you have timestamp on each data that you receive, which is totally normal for any Internet of Things devices. You get the temperature of the room, and you put a timestamp there, and then you get the history of, especially for people detection, also for, like the temperature of the room, not just temperature of the room, but also humidity, the lights were on and off, those kind of things. You get those time series data. And so you would just see them as outliers, spike and level shift, pattern change, and seasonality. I'm going to talk to each one, what it means. Outlier would look something like this. You have your sensor data, right? You're receiving, the minimum and maximum, range for your data set. And then suddenly there was that outlier, that spike. I don't know what happened there, but there's difference, and that's what we're trying to detect. Another one is that spike and level shift, where a specific range, and of course, a specific time of the day, and then something happened. And then there's that spike and level shift. Excuse me. And how it changed from, like in this case, it was the numbers are between 14 to 16, and suddenly it's became 16 to like 18 or 19. So identifying those depends on the use case. Is it an alert or not? Is there something wrong with that device or that machine because of that? Another one is through pattern changes, where suddenly there is a, like, for example, you have a machine in a factory, the usual flow, and then suddenly you're not receiving as much data compared to what it was before. So that can be a pattern change you might want to detect. Seasonality, which is very, you think about the seasonal, every year changes, right? I mean, ice cream is, sales of ice cream is very high around summertime, right? Another one is pizza sales are high around Super Bowl, right? Super Bowl time period. And I think it's Thanksgiving also. Of course, if you're doing trick or treat, and they just want to eat somewhere and eat something. So that's another one. Of course, one classic example of seasonality would be flower shop sales, where you have around February 14, you have your Valentine's Day, so there's a spike of sales there. And then around Mother's Day, that would be another busy season for flower shop. So if you have production issues for Internet of Things, this is how it feels like. It feels like you're getting a bunch of data at the same time and trying to stop a train. And so also when you're working with Internet of Things data, streaming data like this, there's that concept of IID datasets that you have to look into, or that you might be interested in learning more, is where you have the data that you're receiving, the time series anomaly data. One of the requirements in order to process it for anomaly detection is the overall trends does not fluctuate, and they all belong to the same probability distribution. Meaning, a good example of that is on the roulette right here right side, every time you throw that ball, it's the same identically distributed. Uh, it it was not also dependent on the previous readings, or each one is, like in the roulette case, you throw the ball every time you measure. You throw it, uh, it gets thrown every time. So it's not does not depend on the previous one. So that's what makes it IID, or identically distributed and independent data set. So for time series anomaly detection, we can detect spikes and change points. Spikes are bursts in anomalous behavior in our system, and change points is when it persists changes over time, the level changes and trends. So this one, I'm gonna talk about on the Azure side, how you would implement anomaly detection in your Internet of Things application. One of them is through ML.NET in edge devices, right? So you can use machine learning in .NET in order to do deployed in an edge device, how you would do anomaly detection. Another is through Azure Stream Analytics. You have streaming data that gets passed from your edge devices or your gateways, from your sensor data up to the cloud, and you can figure out anomaly from there too, using Azure Streaming Analytics. Another one is through Azure Cognitive Services. Azure Cognitive Services is it's more high-level API calls that you can just include into your dashboards or to your business intelligence. Also, you can run it through your edge devices too. So those are kind of different ways how you would do it in Azure. So just to kind of visualize what I'm kind of talking about, there's this kiosk application. I should have had it open or running here. See if I can execute it. Okay. I think I might have to skip on this one. But it is on GitHub. It's an open source tool or sample code that you might want to look into installing your machine. But it has these anomaly detector and how you would use it. So remember, this is a time series data. Yeah, you have your date, time, and when you measure, and then the measurement itself. Like in this case, there's one value that we're monitoring, and notice how these highlights, especially the yellow ones, that tells me that there's an anomaly. It's out of that pattern. So what it does is it looks at the history. So like this would look at, so we're trying to figure out this last item or this whole time series. And in this whole time series, are there anomalies based from that previous reading? And then based on that, identify if there's an anomaly right there. So that's the whole idea behind this anomaly detection demo. So ML.NET is an open source cross-platform machine learning framework specifically for .NET developers. It allows us .NET developers to deploy on-premise or in Azure or any cloud provider to have some machine learning incorporated to their application. It's a way for us C# developers or F# developers to integrate machine learning into .NET application without any, it's not really required to have an ML experience or data science experience. So it's focused more for the developers. So ML.NET has a time series catalog that you can use to detect anomalies. And so there's different algorithms that's already out there for you, that you don't have to write and code the algorithm. So in this case, I am going to use the detect IID spike right here to change, to predict spikes instead of change points. So spikes would be something like, okay, out of ordinary, there's an anomaly. So let's go through this ML.NET demo. Before I continue on, if there are any questions, let me know and we'll put them in the chat. We'll answer them for you. I will set up this anomaly detection for ML.NET. Visual Studio Code. Oh, I saw that one. Okay. So here's sample data, which is on a comma separated value file. So think about it as this is the reading of this data set. And like in this case, I'm getting the, on my Raspberry Pi, I'm getting the temperature and humidity. And then the time, the reading. And it's all in this CSV file that I want to process. So what I'm going to try to do here is, if you're not familiar with C# or ML.NET, in order to incorporate ML.NET into your program, you would need to add this package reference, which is a Microsoft.ml and Microsoft.ml.time series. And by the way, these examples are on GitHub, and if you want to try them, I will share the link later on. So this is how my program kind of gives me the initial data. So what I have 3 columns that I'm interested in, and I specify which columns I want to read. Remember the message ID, device ID, temperature, humidity, and then the time that I took the sensor data. And in this case, I want to load column 2. Column 2 would be the temperature, right? It starts 0, 1, 2. And then the humidity is 3. Yeah, that's column 3 on my data set. And column 4 would be my enqueued time. So that's just an initial data set that I'm loading from. And this one, this is the conversion data that I want to add 2 more columns to my data, because remember, I don't know if you've noticed that these CSV file, they're all string. And I can't process data that is just, you know, the one that's in quote, double quote. That means it will be read as a string data type. Okay, so there's a question right here about from Courtney. Can you also indicate coordinates as well as you can evaluate data from different location? I guess in terms of identifying, you know, I guess longitude and latitude locations for these. The sample that I'm showing right now relates to one variable that you can pass through your to figure out anomaly detection. So in order to do that, that would require, you know, X and Y coordinates or longitude and latitude that require more. So maybe you can have 2 anomaly detectors that you might want to investigate. There's might require a different type of algorithm in order to do that. But if you can combine them into a single number, that might help out. But longitude and latitude, I don't know if that can be provided as a single number. Like in this case, I'm only going to load the input temperature on here. So they might have some different algorithms that you might be able to use in order to do longitude and latitude. But I'm going to show today is just a single variable that we're tracking in. Like for example, if you have, for your IoT sensor, you want to track in, or combine those sensors together to give you a number, right? To calculate that single number, and then you pass this in for anomaly. That can also be calculated that way. You can, of course, it can get complicated if you have multivariate, like the way they use for credit card companies, where you have always the different, I bet they're using location, right, to identify fraud detection. But that might be on a, more not so basic algorithm, more advanced topic. So on here I am, and also I'm going to predict, right? I'm storing that prediction in a data set. So this one right here, my program would read that CSV data. So in ML.NET, in order to use it, right? In order to use ML.NET, machine learning and .NET, you have to include this using Microsoft ML.NET and using Microsoft.ml.NET. Like in this case, data, since I'm going to be reading some data set. So you can load from a text file. Based from that text file, I can place them into, because I know the format and what columns, that's the class that I was reading in my temperature and humidity data. I'm passing that in to be able to say, hey, I want to read the CSV file and only load the columns that I'm interested in. And it would pass it on this data view. Data view allows us to be able to do data processing instead of like a list where you can have multiple columns. In this case, I want to convert the column, the temperature and humidity columns, and I want to convert them instead of a string. I want to use it as a single variable, meaning a double or a float in this case. So what I'm doing here is I'm creating a pipeline so that when I pass it to ML.NET, it will process each one of the rows on my table, right, on my CSV file, and convert those columns for me. So think about it like how you would do it in Excel, and you add a new column, the temperature column and humidity column, and you're adding a formula there to convert it to a different data set or the different type. So in ML.NET, there's always that fit and transform. You always have to, when you have a pipeline, you fit that pipeline to your data set, and it gives you a transformer. And then that transformer you would use to transform that data so that it would process it. Fit, it's kind of like more for like training, and then this is doing the transformation. So training for your pipeline and then transformation. So I'm gonna try to see if I can run this. Sometimes it helps when we're like debugging at the same time. Excuse me for a second. All right, so we have the data set right here. So it did load my data. And see if I can run the transform. So the transform data would, it's kind of harder for me to show what that output is on here. So I have 5 columns. That's my output column. As you can see here, and then my input schema. So then I pass into that transform data, and I would pass it to this detect spike, pass in the ML context and that transform data. Transform data, that means I already converted those 2 columns into, instead of string, I converted them into double, or the correct data type. So I can pass it to this ML context that transforms, detect IID spike. So these are the different algorithms that you can use inside ML.NET. So you have detect IID spike, you have the detect anomaly SRS, you know, so you may have to research a little bit more which one would work best for you. But what you're trying to do here is, we're passing the input column name, we're passing the temperature, and our output would be the prediction if it's anomalous or not. And this one right here, confidence level, I pass in 95. The higher the value, the less predictions it's going to give you. The lower the number, the more predictions it's going to give you. So the lower that value, that means, you know, the confidence level is low. It was just sometimes it's the tweaking part that might have to figure out which one works best. And then the history length. Remember, the anomaly detection algorithms, they look at the past few readings. Like in this case, it looks at the last 25 items on my list, or 25 past readings of my sensor data. And if there's something less or more, or, you know, it looks at the past 25 readings and create machine learning model for you based on that. Or sounds, you know, it figures out, okay, based from the last 25 readings, is the latest one that I have right now, is it anomalous or not? Or the last number that I have on my list, is it anomalous or not? So let's see if I can run that one. So once you have that detector, we can train. Remember, there's the fit and transform. There's always that combination. Fit is that part where you're training a model, and once you train it based from, like in this case, there's no such training because it's building it on the fly, building the algorithm for you, or the anomaly detection based from that data set that it did receive. So in this case, it would do the transform, and then you'll have your transform data. And then I can pass in, based from that loaded data, then I can read the predictions. So this is where I pass in the transform data, and I want to make it as enumerable, so I can do a for each on my predictions here. So let me try to run it. See, notice how you have your data set, right? Based from that Excel sheet or that CSV file. And this one is the confidence level, or I guess it's how anomalous it is. The lower that value, because remember we specified 95%. So that means 0.05, that means there's a spike that would be detected. Anything below that threshold value, that means there's a spike. So if you look at that number, notice how there's, 29, 23, and then there's a drop between 25 to 20. So that tells you, hey, there's a spike right there. There was a drop of that data. That's unusual based from the last 25 items that I have on my list. And then there's another one right here, it goes through and reads it. And there's that spike again, because, I was 27, like the 20s, and then bam, hundreds. And so that would be detected as anomalous. So it could be a warning that, hey, this data set is wrong, right? Based from that previous numbers that it got from the past. Okay, that's cool. And at least, what I showed you, there's different algorithms how you would do this. This is one way. That it automatically, based from that patterns, right? It's kind of like Spidey Sense from this case, based from the patterns that that it was reading from that sensor data, it was able to detect anomaly. Let's go back to the presentation. Any questions so far? Feel free to place them in the chat if you have any questions. So what's new on ML.NET, the latest one, they have ways to figure out seasonality of your time series data. So sometimes identifying those seasons, it's not easy, especially if you have a big data set. So you can use this for like larger data sets or smaller data set. There's also the root cause analysis you can identify. I haven't used root cause analysis, so I can't explain that. Another way is through Azure Streaming Analytics. I'm not going to explain and focus on this, but I'm going to tell you the idea behind it, where you have your IoT devices right here, or any log files that goes through Event Hubs or Azure Blob Storage or IoT Hub. We're just sending that, and you have another process that would be streaming analytics, where you would receive data from those, and as you receive them, detect if they are anomalous or not. So if you're ingesting, if you're planning a project that relates to streaming data, as you receive it and identify, hey, there's something wrong, but with this data set, or there's anomaly on this data set, this would be a good way. You might want to read more about Azure Streaming Analytics. And if you have projects related to this or planning to do this in the hackathon, feel free to reach out. I am actually on Slack through that AEC channel, and I'd be happy to walk you through how Azure Streaming Analytics and how you can implement it to your project. And of course, based from that, if it identifies, hey, there's an anomaly, then we can send alerts, or we can show it in a dashboard, and all the different ways how you would visualize them. So this is on the Azure Streaming Analytics. If you're familiar with SQL, it's kind of like SQL, but think about SQL, right? Statement is more like static data. This one is streaming data. As you receive the data, you're creating queries on top of that, and identifying. In this case, there's that algorithm that says the same one as we did in ML.NET. I'm going to look at the last 120 seconds data set that I receive from these streaming analytics, and use that as my data set to detect if it's anomalous or not. So instead of the last 120 last readings, you say, give me a time period, and based from that time period, I can detect anomalies. And I can create an algorithm, or I can create a machine learning model that would detect on the fly anomalies. So in this one right here, after it figures out that output, you can detect, hey, is it anomalous or not? Is it an anomaly or not? And then you can identify. And then what is that score, right? Sometimes you want to tweak that score to get better information, get better detection. So what you're trying to do here is you're detecting a spike and a dip. Another one is through change points. You can also use change point, would look something like this, gradual change going up. It won't detect that as anomalous, but when there's that drop right there, that would get detected as anomalous because it's based from this data set and it dropped to this data. Now there's something wrong. So ingestion can be something related to, you have your sensor, Raspberry Pi sensor sending data to an IoT hub right here, and then you have your streaming analytics to do your scoring and then delivering it to a blob storage for analysis or for alerts or however you want to visualize it. So I'm going to skip on this demo. I'm going to focus more on Azure Cognitive Services. Azure Cognitive Services allows us to add machine learning models or add AI for us developers that does not have a machine learning background or they're just not a data scientist. And at the end of the day, it's just an API call, just what we, any API call we have for other systems, right? There's different algorithms or different products that they have. You can do web search vision. If you're working with computer vision, I would recommend to look this one first. And if you're doing speech recognition, speech to text, text to speech, I would recommend you researching more about Azure Cognitive Services for speech. They have one for a language. This one is translation, if you want to do any related translation. But they have something new this year that they came up, which is the decision, which is one of them is Anomaly Detector, which is what I'm going to demo today. And if you're looking into personalized experiences to where, kind of like identifying what the user wants, you give them choices. You give them choices and they select one, and based from their history, the selections get improved. Think about Netflix. Through time, it knows what movies you're going to watch next, right? Or even in Amazon or when you're shopping, it has recommendations. So if you're looking into something about recommendation system, I would look into how to implement personalizer. For Anomaly Detector, I will talk more about that. So identify potential problems, kind of like what we were kind of talking about here. But the difference is instead of integrating it with, instead of using ML.NET or streaming analytics, it's an API that we can just call RESTful API. So monitoring and detecting abnormalities, machine learning to monitor and detect. It does not require us to have machine learning expertise. It automatically, the cool thing here is it automatically identify the best model that would fit to your existing system. Remember, I showed you different machine learning models and how you would implement anomaly detection. It finds the best one for you. It eliminates the need for label training data because it looks at historical data. As you call this API, you pass in all the data it needs in order to train, and it trains it on the fly. You can fine tune the sensitivity, like you can fine tune the how far back you look at your data set, and also the anomaly. There's some variables that you can fine tune it, and it's currently being used by different product teams at Microsoft right now because it's so easy to implement. So anomaly detector features you can do by batch, or you can do it real time. So you have a batch of data, you send that batch of data, and it would analyze that batch of data and figure out different anomalies based from that data set. Or you can say, based from the last one, is the last on my data set anomalous or not? That's when you can use real-time data. So how it figures out different algorithms for you. It has this feature extraction to figure out time series classification, to identify seasonality. There's different algorithms that is available there, and they're improving it. So don't ask me how to implement that. All I know is I can call these APIs and works well for me. So let's do a demo, how that one works. Any questions so far?
Looks like we're good on questions right now.
Okay, good. Let me see if I can connect my camera here. So here's my Raspberry Pi. It has something on top of it, which is called the Sense hat, that gives me sensor capabilities. I think it has the temperature and humidity sensor, and also these blinkly lights or LED lights that I can control and set. And I did install, on this one, I did install .NET on that device, and also installed Jupyter notebooks. If you're not familiar with the Jupyter notebooks, and all these is going to be on my GitHub page. But this is the IP address on my Raspberry Pi, and I can connect to it. And the cool thing about this is I can be in my browser and be able to say, hey, instead of SSH or connecting to that device, I can connect through here from my browser, so I can see contents of my. And this one is using Jupyter Lab. Jupyter Lab, Jupyter Notebooks allows me to be able to run code. At the same time, interact with my code. And I'll show you what I mean by that. So you can actually create, like in this case, you can, if you're a Python developer, most likely you've seen it where you can create notebooks out here, and you can, there's different kernels, how you would, but you can, I've also installed .NET Interactive on this box, and the .NET Interactive would have that capability to be able to run C# code. So think about this. If you're a .NET developer or C# developer, I'm running .NET in Linux, because this is the Raspberry Pi is a Linux box. It's not running on an Intel chip. It's running on an ARM device. And I have .NET running in the browser. Not in the browser, but I can program in the browser this way. So I can say I want to have a C# program here and say console write line AEC Hackathon, going right here, and I can say run. And what it does, it spins up a C# program for me that would run that and give me the result below it. So it's easier to kind of grasp what's going on. And I can say hi. I can rerun it again. Say hi. Shift enter to run it. And if I want to say, this is cool, I can rerun that same code, and it gives me that result back and forth. So it's easier to interact with your program, kind of like a, think about it as a command line interface, but you can go back to your previous code, run it, rerun it again, go through that. So you can, if you're a Python developer, there's a way you can do this. Most likely you've heard of it too. So in this case, if you're not familiar with .NET, as I'm focused on, because I'm a .NET developer, there's a way you can actually, I think it's on GitHub, where you can, let's see if I can get to that, .NET IoT. So this one right here allows me to talk to my IoT devices using .NET. And you can install it using NuGet, and you have to add this system.device.gpio and IoT.device bindings. Of course, you can do this in a regular C# program if you're a C# developer, but what I'm showing here is that this is how you add NuGet packages to your application. You are, and then you identify which one and what version you're wanting to incorporate. So this system.device.gpio opens up a way you can connect to your Raspberry Pi. And then this one is IoT.device bindings. This IoT device bindings, if you have different sensors that you want to work with your IoT devices, these are some of the sensors that you can incorporate that they already have drivers for you. So if you're going to incorporate accelerator, gas sensor, light sensor, barometers, there's one way you can identify them. What I'm using right now is this Sense Hat. This Sense Hat is the one that I have on top of my Raspberry Pi that can read sensor data and control it. So I'm gonna do is wonder if I can paste it on the chat. Let's see. I don't think I have a. Anyway, I'll just if you need the link to the GitHub page for .NET and IoT, I can share them with you. So this one, what I did was, so I can run this again, and this one would download the NuGet packages. See if I can wake it up. Sometimes it sleeps after a while, and it would. And this is how I can change the color of my Raspberry Pi. So try to visualize it a little bit, and I'm going to try to hide this part right there, and say I want to make this green. So this Sense Hat LED matrix. So I put using IoT device.sense hat, which is part of the documentation on that. And if I want to change that color to this Raspberry Pi to turn green, there you go, it's all green, right? Do it black, that means turn it off, it's all set to 0. So I did there. This code, what I'm doing here is I'm reading the temperature data. As I read the temperature data, I would wait 1 minute. And this one is using asynchronous stream. Asynchronous stream allows me to read the temperature data, then return back to the color, and then after it calls next, after 60 seconds it would call again. So the way I'm using it here is I do a wait for each. As I read 15 times, I would receive the data. It would go here. Once after 1 minute, I would get the result, and then I would add them to my list of tuples, meaning you have the date, time, and double. I will add that temperature data, and then it would go again here, would wait 1 minute. After it's done waiting for 1 minute, it would give me another temperature data, and that I would receive it here and would add it to my list, and it goes back and forth. They kind of work together in tandem to receive all my temperature. And data would look something like these. I added a way you can round up that number. The reason why I say that, because the API, the Cognitive Services, the Anomaly Detector API, kind of wants a discrete values, meaning they're all kind of like the same. I'm specifying that my measurement is every minute, so I'm giving it every minute data. So if I specify every day, you just specify date, and it would figure it out. But since I'm specifying every minute, it kind of wanted to see that it's minutely, right? It's every minute. So I already ran this part right here. It would give me all these temperature or data readings. And then this is the anomaly detector. The anomaly detector can read. This is the NuGet package that you would incorporate to make it easy to run it in C#, where you have a list of all the data set. So like in this case, what I'm trying to do is I'm trying, to get this request populated. So what this one does is grabs every data set on my list, right? After that, I create this request. This is what we're going to send up to Cognitive Services, because at the end of the day, what it's expecting is a list of all my, all the data set, this previous data set, so that it will train the machine learning model automatically. And then based from that, I specify, hey, my data set is every 1 minute. So you can do it every 5 minutes. So you change the period to 5. If you want it every day, there's minutely, there's daily, there's monthly. So you can change that. So depending on the data that you're sending it to Cognitive Services, the Anomaly Detector, you specify it here. So what this one does is it would detect the anomaly from the last point in the series. So I pass it, I call that, once you have that client, you call, hey, is this last data on my list anomalous or not? And then it would give you the result, passing that request that you built here. In order to use Anomaly Detector, you would have to create, and you have to create an API key. You have to have an API key. Like, I don't have that sample, but you go through that list, you create an API key. And once you have the API key, you have to, it will also give you the endpoint and the credentials, right? The API key. So those are the two main important things that you need to have in order to run this. So I already have that set up on mine. There's lots of tutorials how you can do that through Azure. And if you need help setting this up, I'm available to be a mentor, to be able to set and get those subscription key and endpoint for you. And I believe there's a free version of these. Just have to go through the Anomaly, through that website to get those keys. So once you have set up that, in this case, what I did here is, okay, grab all my data set. On my last data, I want to fake it because, it's temperature readings. I want to put the last one, I want to put 200 instead of like 100, so that I can force that, hey, it becomes anomalous. And then I pass that in to my API, all my previous data set, See if I can run this one now. So based from that data set, if it replies back as anomalous, then the LED matrix would turn red. If not, just leave it alone. So let me see if I can get that for you. So here's my Raspberry Pi, and I'm going to run this program right there. And look, it turned red. The reason is that because my last data set, I ran this twice, so my last two data sets is anomalous, but it detected, hey, my last one, this data is anomalous. This anomaly is true. That's why it turned the LED matrix to red. And I'm going to turn it off because it hurts my eye. Do that. Cool. Isn't that cool? So we're able to read sensor data and send that sensor data, our list of sensor data, up to the cloud, right, to Anomaly Detector. And it built a machine learning model for us to detect if the item on that list has anomaly or not. And then it returned back to us, and then we were able to control our LED matrix to alert our users. All right. Any questions so far? Isn't that cool?
That's cool, man. So. Yeah. Yeah, we're definitely doing good on questions.
Yeah, cool. So where can you use this anomaly detector? You can use it for C# if you have a JavaScript. There's examples out there, and I can send you this link or a link to my presentation also that has all these links. You can use it for JavaScript if you're a Python developer. You can also include it in your Python program. You don't need the fancy thing that I was showing you today where it runs in the browser. You can, regular C# or regular Python JavaScript will do. It's just a good teaching tool. That's the reason why I did it in Jupyter Notebooks. You can also incorporate it to a Docker container. So if you can deploy them in your server or your edge devices without if you have a sparsely connected internet connection, you can incorporate the anomaly detector. Of course, it does charge you. There's a fee. I think I don't know how many calls, but anyway, but it's a lot of calls before it starts charging you, because it's a subscription type. You can also incorporate to your Power BI, meaning if you have a chart, if you have something that you're visualizing for your buildings, for any AEC type of application, and you want to incorporate some charts and want to create anomaly detection, or you can batch anomaly detection. You're showing it inside Power BI. You can incorporate anomaly detection into your chart, into your data set. And there's ways you can do that. And of course, if you have streaming data through Azure Databricks, there's also a way you can do that too and call Anomaly Detector. So at the end of the day, the best superpower that you can give to your Internet of Things project is a Spidey Sense, which is anomaly detection. That allows us to be able to, based from that sensor data, detect, hey, there's something wrong, and alert properly and identify those issues. If you're interested in getting links on this presentation, or you can use your phone QR code and send you that link, or you can type in that bit.ly Spidey Sense anomaly to your favorite browser. You'll have all the tutorials there, or sample what I demoed today. And if you haven't gotten bitten by a spider bug, to get Spidey Senses into your projects, here you go. So if you're interested in learning more about me, my name is Ron Dagdag. I'm a software engineer at Spacee, where we do a lot of augmented reality applications. I'm a Microsoft MVP. If you're interested in learning more about my projects, the best way to contact me is through LinkedIn, Twitter, and email. I appreciate your time. I appreciate you geeking out with me about Internet of Things, Spidey Senses, Spider-Man, and Anomaly Detection. Thank you very much.